In this video, we are going to explain a couple of terms used in regression analysis in econometric model. The first one is R-square. R-square basically explains the fraction of variation in y due to x, or it is a predictive power of x for y. It is unitless because your sum of squares of sum of squares due to regression divided with total sum of squares, so units cancel out. Standard error of the regression basically is, it measures the magnitude of a typical regression residuals in the units of y. Now, yi equal to yi hat plus ui hat. Please keep it in mind that the whole objective of any econometric model is to split observed value of y into two parts: systematic part and random part. So long as you have split it into systematic part, which is regression equation, plus some random part, model is okay. But if some random part, some systematic part is here, then you must revise your model so that pattern, some systematic part, that is basically pushed back here. So we include more variables. Now variance of y equal to sample variance of y plus sample variance of ui hat. As I mentioned earlier, that we always have only sample data. So sum of squares, total sum of squares kya hai? Yi minus y bar square. Here you have y bar. Explained sum of squares plus residual sum of squares. So yi hat is your fitted line and its mean, its square. This is your sum of squares due to regression, or this is called explained sum of squares, and this is called total sum of squares. Here you have y bar. Please keep it in mind, this is always fixed. For example, we have 420 districts. This value will remain fixed. These values may change depending upon how many x variables, explanatory variables you have. So r square is equal to 0 means explained sum of squares equal to 0 means x has no predictive power. R square 1 means that total variation in total sum of squares is equal to explained sum of squares. Usually it's not the case. R square is between 0 and 1, so long as you include intercept in the model. For regression with a single regressor x, R square is simply square of simple correlation coefficient between x and y. Standard error of regression is measured by ui hat minus u hat bar. We know sum of residual is 0, so mean of the residual is 0. So this will be equal to 0 here, and your standard error of regression will be ui hat square n minus 2. N minus 2 is due to because we divide it by degree of freedom. So here you have beta naught and beta 1, two parameters which are estimated from sample. So your 2 degree of freedom is reduced n minus 2. We divide it by n minus 2. If we divide it by n, it is called root mean square error. You have ui square, it's sum of squares of error, and you divide it by n. So this is mean square error, and then you take its root. It is called root mean square error. The difference is here you have n minus 2, here you have n. If n is large, then it doesn't make any difference. Then it does not make much difference that whether you use root mean square error or you use standard error of regression, because n minus 2 will be so close to n that this divisor will remain more or less same to each other. So there will be not much difference between the values of standard error of regression and root mean square error. Let's move. This I have already explained that why you need to divide it by n minus 2 instead of n minus 1, and what is the difference between root mean square error and the standard error of the regression. So look here, last slide of this video. Test score is equal to 698, that is your intercept. Intercept has no economic interpretation here, minus 2.28 into student teacher ratio. Class size R square is 0.05. Standard error of regression, spread around this regression, is 18.6. What does this mean? R square is very low. Does it mean the class size has no effect on test score? Standard error of regression is high, because plus minus 2 standard error of regression will make your guess more than 37 units on or off. So therefore your your standard error of regression is high when we compare test scores. Okay, so what does that mean? Is it a bad fit, or student teacher ratio is irrelevant variable here? Answer is no, because there may be other variables, there may be other variables in the model which also play role along with class size. I mentioned here, I would like to point out here, R square is not a criteria for good or bad model. It may be a criteria for good or bad fit, but it's not a criteria for good or bad model from causal point of view, that whether model is really fantastic if R square is high and model is bad if R square is low. That's not the criteria for measuring the effect of class size on test score. So we'll explore this question in detail in our upcoming videos. Again, I would like to point out that our research question is, does class size reduction lead to high test score? Thank you for watching. Take care.